Good evening, guys. I'm going to make a video presentation about uh, tropical governing zone. So the vessel will be in a tropical governance zone. Governing zone. This is a tropical. So and they will be loading at birth. So let's go, guys. Let's start. Example 5.2. Mbinara is to load full to her tropical draft density of dock water in load port is this is the local density of 1.014 tons per cubic meter and has the following weights remaining on board on departure from load port. So this is the ROB when the ship's going to depart. Fuel oil 1193, diesel oil 18, lube oil 12, freshwater 295, ballast 45, and constant is 210. Her draft is limited only to tropical load line throughout her voyage. So he will just maintain his draft of tropical maximum draft of throughout her entire voyage. Okay. Then this is the question. Fine. Number one, the quantity amount of cargo to load assuming that there's sufficient fuel for the voyage. So what will be his maximum cargo to load upon departure at loading berth? The maximum permissible draft if she's floating in water of density. So what will be his draft when she floats at berth at 1.014 tons per cubic meter? This is the loading port, the density of the loading port. Her draft when she proceeds to sea at 1.025. So what will be her draft when she is at ocean or at sea? And number 4, if she's about to complete loading and floating at a draft of 9.63 meters in water density of 1.014, find the quantity of cargo remaining to load. So what will be his remaining cargo to load when he reaches this draft of 9.64, 9.63 and the density of 1.01. Okay, so this is the solution. So investigate, guys. So the determining governing zone is tropical zone. Now, know the draft and displacement of governing zone. Okay. The governing zone is tropical zone. What will be the maximum draft of this tropical zone? The maximum draft of tropical zone is this one. Departure draft salt water will be 9.749. Okay. So and the displacement is 31588. So let's check this Mbinara. Then we go to capacity table. So what is the tropical? The maximum drop is 9.749. This one. 9.749. Displacement is 31588. So this one, guys. So tropical will be the maximum drop is 9.749 and the displacement is 31588. Okay. So this is it, guys. 9.749 meters and displacement, departure displacement is 31588. Okay. And you total the cargoes on board, remaining cargoes on board. the fuel oil, diesel oil, lube oil, fresh water, ballast, and constant, and the total weights on board will be 1773. Okay, now you put down here the total maximum displacement. Departure displacement is 31588 minus your light ship or light displacement, which is 6772, and that will be the dead weight, 24816. Dead weight minus your weights on board, which is this one, 1773, and that will be your maximum cargo to load. So the answer is your maximum cargo to load will be 23,043 metric tons. Okay, that will be the loadable cargo. And go to number 4. Find the departure. So let's check this one. I forgot to check this one. Maximum draft is 9.749. So check. $9.749. Is that correct? $9.749. Okay. $9.749. Okay. And its displacement will be displacement will be 31588. Okay, so this displacement is 31588. I'm sorry, 31588. Okay, so we got now this maximum cargo to load will be 23,043 metric tons. Okay, then find the departure draft at when she's floating at a density of 1.014. So the formula is lookup density, your actual draft times constant of 1.025 over the local density. So your actual displacement is this one, 31588, which is the maximum draft of the tropical zone, times your constant of 1.025 over the local density of 1.014, and the answer would be the displacement would be 31930.6 of the water. We will check this, guys, if it is correct. Investigate this one. So we go back to Imbinara, then we go to this how to find draft trim when handling weights involving large stages. So the draft was 9.749. Okay, and density is first water. How much would that be? So this one is 31588. So how much would that be in water of 1.014? So that will be 31930 or 9.749. 9.846. We'll check. So that will be 31930. 31 31930 0.6 or 0.5. That will be drop corresponding drop will be 9.846. We will check here. Corresponding drop is 9.846. Okay, and we will now find the sinkage. According, if you are in the traffical zone, this will be the formula. Sinkage departure draft of one in local density 1.014 minus pressure drop, which is this one, the water is 9.846 minus 9.63 will be, your sinkage will be 0.216. So let's check, guys. Your pressure drop, your departure drop of local density 1.014 is 9.846. Okay, so we'll check, and this will be your pressure drop 9.963. Okay, let's check. How do you get this 9.63? Okay, this will be pressure drop. This is because you stop loading when you reach this drop. When you reach this drop and with the density of 1.014. Okay, so 9.63. So you go here, nine point six three, 9.63, bigger, 9.63. Okay, then as a requirement, or as I always do, you take the readings of your actual major drop port to starboard. So you put here 9.63, 0.63, and 9.63. Assuming there's no list, so this will be this will be the duct water. Okay. Duct water midship, and the departure drop is 9.86, 9.846, 9.846, 9.846, 9.846. Okay. 846. Sorry. 846. 846. So your sinkage is 0.216, which is this one. 0.216. Okay. Then compute the remaining cargo to load. So this computation is 759 metric tons. So what is this formula? Sinkage times TPC times 100 times your local density over constant of 1025. So your sinkage is this one, which is 0.216 times your TPC of this one. It is a TPC of 9.63, which is your present drop. We'll check. TPC but I use the I usually TPC is 9.63 is this one, 3552 35 3552 times 100, which is this one, times local density. Multiply this one, you will get this figure over 1.025, and the value will be 79759. But you see, I don't use this 353552. Why? Because in my program, the TPC that I use is your departure draft, which is 9.8846. This is the departure draft or the final mid draft, and the TPC is 3567. So 3567, and the remaining cargo to load will be 771, which is this one. K9, which is the sinkage, times 100, which is constant, times your TPC. TPC is S3. This is S3, number 3. So I use this TPC, this one, 9.86, 9.86, 846, and 3567. And remaining cargo to load will be 771. But according to this formula here, it's 759. Okay, so I don't use this times density or local density time over your constant of 1025. Now this is cargo to load. Okay, and there's another solution. So the salt water of 9.63 is 3166 times the local density over the constant, and the new displacement will be 3083232. This will be the density of or distributed duct water. So we will check duct water. Okay, put here 7. Nine six three 963 963 63. Displacement is 316 and what will be the water will be 3131. Okay, let's see this one. How much would that be? We should get this figure. Okay, 301. Okay, 30. See, get this one. 014. Get this one. The displacement is 30832. 30832. 30832. So this one, if from 1.025 that is the salt water, your displacement is 31166 31166, which is This one. Displacement is 3166, so almost the same. Okay, so 9.63, the displacement is 3116.7. It's almost the same. Okay, and we go back to 7. Now if we change this to the local density 1.014, 14, this, ba't hindi ng kwanto? Okay, 1.014. Hindi na nabago to. Here you are. Displacement is 30832. 30832. 30832. So your final displacement upon departure is 31588, and your present displacement will be this one, 30832 will be 756, but the other one is 759. Three times difference. But according to my program, you only have to load 771. Okay, and they have the computation, manual computation was 759 and 756. 759, 756. Okay, but we'll just stick to this program. So the recommended to load was 771. Okay, so we go down, scroll. Let's put in the other side. 9846, 9846, 9846. Nine point 63. Where you stop loading. 9.63, and the depot 9.63. Take this actual reading on your mid-draft, port and starboard 9.63. Okay, and your departure draft is 9.847. Is that correct? 9846 and 846. Okay, so the recommended drop is 71. So check this formula here. K8, which is the sink age, which is 0.216 times 100 times M3, which is the TPC. So TPC will be this one, M3, M3. So 3567, which is this one, 9.446, which is already 4, round up to 85, that will be 35.67. So with this formula, you will get the value of 770. So you go down, then you put this value here. What will happen if you load 771? 771, and it goes here. What will be the mid drop? 9.8461. So almost the same. Sinkage is 0.2161. Almost the same. Okay, but the problem or the sample stops only on the remaining cargo. Stops only here. So the remaining cargo to load only stops here. So what if we continue with this program? Let's say my trimming hold is, so I go to, from this one you go to trim holes 2. I go to trim holes 2, then I make this a little bigger. Okay, then this is the remaining cargo to load, 771, 77. Let's say I want to trim it in hold number 1 and hold number 4, and I will have an even kill if in my departure, no trim. So I put here 0. How much would I load in number 1 and number 4? So in number 1, I will load 312. Let's say I will load 312. Put here 312. And how much will be in number 4? 459. Number 4 will be 459. And what will be the drop? Departure drop. Departure drop is 9.85. Forward up will be 9.85. Trim 0, and the main drop will be the same, 9.846. So your deflection is 0. Main drop is this one. This should be your main drop. Okay. Put this one. So you have a 0 deflection, and your mid drop is this one. Mid drop is 8461. This one. Okay. So by you have normal cargo is 312, 4 is 459, which is the same here, and your departure drop will be 9.85. So you have a trim of 0, and your main drop will be this one, and your mid drop, so you have a 0 deflection. But let's say we follow the what was written in the problem. It says we follow this one, 759. What will happen? 759. So we put here 759. 759. Okay. And then we go to holes 2. Go up. So you have here 759, 759. How much will be in hold number 1 and number 4? So it says number 1, 0 trim. Number 1 will be 308. Okay, put 308 here. 308. So number 4 will be 451. Here, 451. And how much will be the drop? Drop is even kill, 9.85, 9.85, 0 trim, and deflection. The main drop is the same, 9.846. You have a deflection of 0. So on the other side, we have number 1 is 308, number 4 is 451. The same here. And what will be your draft? 9.84, 9.84, and you have a zero trim, and your min draft is 9.843. Okay, but selling draft is 9.846. See, why 9.83? Because you have lesser cargo. Your cargo is only 515, and it's not. It should be 771. So if you put 771, this should be 9.846. Exactly the same with your departure draft. But your mid draft now is only, min draft is 84, but still you have zero deflection. Okay. If you have any comment, guys, whichever you like, this program or the manual computation, which is this one. So it's really up to you guys which one you prefer. Okay, but for me, I use this program. So I think it's more accurate for me, because this final departure draft, you will use this TPC for getting this remaining cargo to load. So for me, this is one I would like to use. Okay, so let's go back to 771. Okay, what will be his departure draft here? 9.846, which is almost the same, and the sinkage is 2.216, so almost the same here. So we go to number 2, trim holes 2. You got now the trimming holes, the trimming cargo. So how much would be in number 1 and number 4? We have a zero trim, so now number 1 should be 312. So there 312, and number 4 will be 459, and your draft will be 9.85, the same forward and up. And look at the mean, 9.846, not 43. See, so you still have a zero flexion, and it will be the same here, the other side. Yo, 9.85, trim 0, and your main is 9.847. But you have this main rough here, so it's the same. So that's it, guys. If you have any comment, please write in the comment section. And if you like the video, please click on the like button, share, and subscribe. Thanks for watching. Have a good day.